Algebraic reasoning, chapter 1.4, exercises 13 through 21. And I'm going to go over these odd number problems, 13, 15, 17, and 19. I don't think we're going to get to 21. Yeah. Okay, for questions 13 through 18, identify if each table represents an exponential function or not. Table represents an exponential function, write the function relating variables. So we're going to, like we did in the previous video, look for an exponential function, and that'll be by multiplying. So 4 times 8 equals 32, but then does 32 times 8 equal 108? No. Is there anything we can multiply by 0 to get 4? No, there's not. So there is not a common ratio. We'll say there isn't a common ratio and now I'm going to put dot dot dot, which means therefore not exponential. Okay, let's go ahead and box that in as our answer. Okay, next we're going to go to problem 15. All right, we will just test what times 50 equals 25. Well, 50 divided by 2. So we will say times 1/2. So 50 times 1/2 is 25. 25 times 1/2 equals 12.5. And finally, 12.5 times 1/2. It's going to be 6.25. So common ratio R is equal to 1/2. So the function is exponential. Now it's not exponential. It's not an exponential function because the common ratio is 1/2, but because there is a common ratio. So next it says, if the table represents an exponential function, write the function related to variables. So what we've talked about in this class earlier is that the main function, exponential function, is this: y equals a times b to the power of x. And we talked about a being what? The initial value. And we've talked about b being the base, or in this case we could use our common ratio r, right? That would be our base. And your initial value is going to be the y-intercept. Now, when we were looking, I think in chapter 1.1 about the geometric sequences, I think we started out with the first term. But here, the term 1 and then what it was. But here, we have a y-intercept. So our function should be, and we'll test it out, y equals our initial value, which is 50, times our base. And what is our base? 1/2 to the power of x. And then we just test it out. If we plug in y Plug in 0 for y sub 0 is going to be 50 times 1/2 to the 0 power. Well, 1/2 to the 0 power is 1, so we're going to get 50. So that checks out. Next, we could try putting in 1 for x. Y sub 1 is equal to 50 times 1/2 to the power of 1. Well, that's going to be 50 times 1/2, which is going to be 25. Check. And we could go on, but we verified it here, and we're just going to go ahead and box in our correct answer for our function relating the variables. Okay, next, problem 17. Let's see if we have a common ratio. And to do that, we'll take 6750 divided by 4500. See what we get. Next, we're going to take 10,125, and we're going to divide that by 6750. See what we get there. And finally, we're going to take 15,187.5 and divide that by the prior term, which is 10,125. Okay, 6750. Let's go here. 6750 divided by 4500. We get 3/2. Next, we're going to take 10,125 and divide that by 6750. And we get the same thing, 3/2. And so it's looking pretty much like that's where it's going to be. I'm going to take the last one, 15,187.5, and divide that by 10,125. And we get 1.5, which is the same thing, right? Equivalent. So we will therefore say, we'll just say 1.5. So since there is a common ratio, the function is exponential. Okay, now for that equation, we had from before y equals a times b to the power of x. Test it out. So we'll say y equals our initial value. So we'll say initial value a is what? 4,500. Base b is equal to our common ratio of 1.5 or 3/2. So we'll say y equals our initial value 4,500 times, I'll just put it as 3/2 instead of 1.5 to the power of x. And for the first one, if we have y sub 0, testing out here, we get 4,500 times 3 halves to the power of 0. Well, anything with 0 power is 1, so we're going to get 4,500. That checks out. Next one, we can say y sub 1 is equal to 4,500 times 3 halves to the power of 1. Well, that's going to be 4,500 to the power of 1. We're going to get 3 times 4,500. That's going to be 13,500. And we're going to divide that by 2. And for that, we're going to get 6750. Check. So this is going to be our equation right here. Write the function relating variables. This is it right here. Y equals 4,500 times 3 over 2 to the power of x. Okay, next, let's look at problem 19. And 19 is part of a set, really, in that for 19 and 20, use the situation below. And this is a sheet of paper having an area of 100 square inches and cut in half every time. We can see a pattern here where to get from 100 to 50, we are multiplying by 1/2. And likewise, to get from 50 to 25, we're multiplying by 1/2. So we can, at the right here, just kind of extend the table to further analyze. So we have cuts x, area of one piece y. So we have, after 3 cuts, we're going to take 1/2 of that 25. So that's going to be 25 times 1/2 is going to be 12.5. For 4, we're going to multiply by 1/2 again. And so that's going to be 6.25. And finally, our 5th cut, we're going to multiply by 1/2. And for that, we're going to get 3.125, I think. And that's going to be after 5 cuts. And these are all in, let's say, square inches. Yeah, units of square inches. So we will say 3.125 square inches, which we put inches squared like this. And that'll be after 5 cuts. Okay, and so that's as far as we're going to go in these exercises today in this video lesson. Good luck, and thanks for viewing.